Good morning. So I'm Stephania, and I'm going to give you an update in the NIR implementation into the Louisiana cane payment system. I know I've been talking about this topic for the last years, so this is going to be an update. For the ones that are new and are not related with the Louisiana cane payment system, this is going to be a short introduction. So here in Louisiana, some of the drugs that arrive to the factories are sampled. So we take some kilograms of sugar cane, then we shred the cane, then we press the juice, and we're going to get juice and pressed cane. Then we analyze the samples and we measure bricks, pulp, moisture, and sediment. And then based on those analyses, we are going to calculate the theoretical recoverable sugar. Based on that numbers, the factories are going to pay to the growers for that sugar cane they deliver. What's the idea with this project? We are going to introduce the NIR. This equipment is going to replace the refractometer, the polarimeter, the ovens, and we are going to be able to introduce the trash analysis. So we are going to know how much leaves and soil we are receiving with the sugar cane. With this implementation, we are going to be able to save money because we are not going to need all those equipments. We are going to save money in the glassware that you are using, octapole, clear pole, filter papers. We are going to replace all that. Of course, we are going to reduce the time of the analysis because instead a moisture analysis that takes 3 hours, we are going to analyze samples in a couple of minutes. With that, we are going to improve the efficiency of the laboratories, and therefore, they are going to be able to analyze all the trucks that arrive to the factories. That's the idea. So what's the NIR and how it works? Dr. James already explained you how this equipment works, so I'm going to try to do it faster. This is the NIR we are using. It's a Bruker and MPA 1 and 2 equipment. We put the sample, and we put light, near-infrared light to this sample. Some of that light is going to be absorbed. The rest of the light is going to be reflected, transmitted, depending on the sample, and we are going to measure with this equipment the diffuse reflected and the transmitted light. The NIR is going to give us this. This is a spectra. Each line is a sample, and that's all the NIR is going to give us if we don't calibrate it. Why? Because each sample that we are analyzing with the NIR is going to, is going to have this representative curve, and we also have to analyze the samples with the normal methodologies you are using in your labs. Then we are going to develop the calibration models, so the NIR is going to learn when it receives a curve like this, it's going to know the results. When we have these calibration models, we are going to be able to measure unknown samples, and we are going to get the results. Right now, we are working on the calibrations model. The steps to implement the NIR into the Louisiana system, it's all the steps that you are seeing here. First, we have to set up the equipment. We have to sample a lot of samples. Right now, we are close to 2,000 samples. We have to develop methodologies to be able to measure trash because we don't have those methodologies. Then we have to develop the calibration models, and finally, when all that is done, we are going to be able to implement the NIR into the system. For the first step, we already have 2 NIR systems. One of them, the oldest one, was installed in Cora, Texas for the last 3 grinding seasons. The other one, which is a new version of the NIR, was installed in Westfield for the last 2 grinding seasons. Right now, we had measured around 2,000 samples of shredded cane, around 900 samples of pressed juice, and around 800 samples of pressed cane. The analysis is pretty simple. As you can see here, this is the way we analyze shredded cane or pressed cane samples. You just put the sample in this compartment, and for the juice samples, we just use the probe here, and it's pretty easy. Now, for the calibration models, I'm going to talk first about pulp and bricks. As you know, for pulp and bricks analysis, you are normally analyzing pressed juice, but we want to develop calibration models for pulp and bricks in shredded cane, because if we are able to do this, we are going to skip the step of the hydraulic press. The problem, and last year we already had some calibration models for pressed juice and shredded cane, but the problem with shredded cane is the sample is super heterogeneous. As you can see in the picture, we can get really long fibers, and that could interfere with the NIR analysis. Therefore, we try to blend the sample to have a more homogeneous sample, as the one that you are seeing here, and we analyze if that could improve the calibration models of the shredded cane sample. For the pressed juice samples, last year we had really great results for pressed juice, but we wanted to improve that even more, and we changed a parameter that is called sample preamplifier gain in the NIR. I'm just going to call it A and B, and just to try to see if the calibration could improve with that a little bit change. Those are the results we have so far. And the conclusions that we are getting are the same conclusions we got last year. It's better to keep analyzing pressed juice instead shredded cane. You can see the R square is around 98 for pressed juice, instead the around 80% when we are analyzing shredded cane. And even though we blend the shredded cane, the results didn't improve. And even though we try another parameter in the analysis for pressed juice, the result didn't improve either. So we are going to keep analyzing pressed juice with the parameter A in the NIR. After all that work, we have 3 calibration models for 3 factories right now. And you can see that all the R squares are above 90%, which is great. Some of them are around 98%. And in the ideal scenario, we can combine all the data and we can create just one general calibration model for all the factories. You are going to see that the calibrations are pretty good, around 98 for bricks and 97% for a pole. So this is just confirming results from previous seasons. The NIR is really promising for analysis of juice for the payment system. Now, we wanted to just corroborate the precision of the NIR analysis. So we took 2 random samples of juices. We measured each sample 8 times with the normal methodology for bricks and pole and for NIR, and those are the results. You can see the measured bricks for both samples is around 18.6, and with the NIR we are getting the mean value exactly the same. It's 18.6. I know this box looks a little lower than the other one, but the difference is only on the second decimal place. So here we are getting 0.62, here we are getting 0.55, sorry. If we convert this to TRS, we can notice the difference between both, but these are really small differences. We can see here 184.9 and here 185.2. With the second sample, the difference is only 1 decimal unit. So the results for bricks with the NIR are pretty promising, as I was saying. For pole, we did exactly the same. The NIR is giving us a slightly higher pole values than the real pole value, but the difference is not even statistically significant. And if we turn this into TRS, we are getting the same, a little higher TRS values with the NIR, but again, the difference is not statistically significant. Now, for moisture. From last year, I show you some calibrations, and this is one of those. The calibration was not good at all. The R square is only 60%. And I was just thinking, what can I do to improve this methodology, to improve the calibration? So I went back again to the methodology to measure moisture. Because remember, if we calibrate the equipment using a methodology that is not accurate, my calibration is not going to be accurate again. So I need to be sure the methodology I'm using is accurate enough. And I checked the moisture methodology we are following in the factories. In the factories, we are drying samples at 100, 150, 170. And I took a couple of samples of pressed cane, and I dried those samples using those temperatures, but in this case, I also include drying the sample at 100. If you can see the moisture methodology, you should be able to dry the sample until you get constant weight, right? But if you zoom in this graph, you can see that when you dry the sample at 140 and 170, the weight is never constant. The moisture is always increasing. So that means we are having a problem with the moisture methodology the factories are using. On the other hand, if you measure moisture at 100, you can see that after 25 hours, I know it's a long time, but after 25 hours, the moisture is constant. So that it's only confirming that the temperature we are using in the factories is too high. And when you see the pictures of the samples after you dry the pressed cane, you can see at 100 the sample looks normal, but at 140 and 170 the samples are really dark. That only is proving that you are burning your sample. When you are burning your sample, you are just releasing organic acids, you are releasing other components, and when that happens, you are accounting that as moisture, and it's not. So that's why the moisture of those two temperatures is higher than the moisture at 100. So now I decide to move forward and use this methodology at 105 because that's the methodology that the temperature that ICUNSA recommends for this kind of samples. So I compare the calibrations models at 160, 105, and I also develop calibration models for moisture directly into the shredded cane. We don't measure moisture to the shredded cane, so I measure this moisture under vacuum at 60 Celsius for 48 hours. And I just keep using the methodology about the blender to see if that improves the methodology results. Those are the results. We can see here, if we compare shredded cane versus pressed cane keeps the better results. We are getting better results with pressed cane if we use the ICUNSA methodology, if we dry the samples at 105. Why? Because as I show you, that methodology is more reliable, and therefore we are getting better calibration models in the NIR. And now we move from 60% in the R square with the previous methodology to 88% using the ICUNSA methodology. So this is promising right now. I'm happy with this result because in other countries, they are already using NIR for moisture and they are getting good results. And now this is just proving that the NIR could be used for moisture analysis too. I also checked the precision of this methodology, even though the R square is not the higher one, but 88 is still acceptable, so I checked the precision of the methodology, and I compare. First, I want you to focus on these results. Measure moisture at 105 versus measure moisture at 160. And as I showed you before, the moisture at 160 is significantly higher than the moisture at 105. But why? I already showed you, because we are burning the sample, not necessarily because that's the real moisture that we are getting in our samples. Now, if we compare the measured moisture at 105 versus the predicted moisture by the NIR, the results are really good. We are getting really close moisture results, 43.3 versus 43.7 for sample number 1, and for sample number 2, the difference is again around 0.8 units. And if we convert this into TRS, of course, we are getting a differences around 1 point in TRS between moisture at 105 and moisture with the NIR. The TRS is not exactly the same, at least it's not lower. That was something that was really concerning people about the NIR. And now finally, the last methodology that I'm working on is LIPS, because we want to measure trash content. From previous years, we already developed some preliminary calibration models using mixtures that I prepare. So I was taking shredded clean cane, I was mixing that with leaves, green leaves and brown leaves. And in order to try to produce a sample that is similar to the cane that you are receiving in your factories, I also add soil to those samples, because I already proved in previous years that soil can affect this calibration model. So that's why I included soil. And we did these mixtures with 4 different types of varieties, the most important ones here in Louisiana. But we have a big concern about the soil, because last years we tried with only 2 types of soil, and in Louisiana we have thousands of types of soil, and we just want to generate a really robust calibration model for predicting leaves and soil. Therefore, we came up with this table. It's a huge table, but it's basically showing the types of soil that we have only in the areas in Louisiana that are planted with sugarcane. You can see that the first types of soil are seed loam types of soil, and that accounts for almost 40% of the area in Louisiana. How we came up with this table? We took this map from the Cropland Cross from the USDA that shows in the purple areas the areas in Louisiana that are planted with sugarcane. And we cross-validate that map with this second map, which is the Web Soil Survey from the USDA again, and we cross-validate the information. So based on that, we got this table, which is showing only the types of soil that we have in the Louisiana areas planted with sugarcane. And those were the soils that we used for our mixtures. Now, we wanted to know if the type of soil and the variety affect the prediction of the NIR of leaves. And on this table, on your left, you can see that the different type of soil indeed affect the calibration models. We can have a calibration with 96% R² with this type of soil, but it could go down up to 89% when we are using this other type of soil. When we analyze the variety also have an effect. With this variety, we can get a 96% R², and with this one, we can get an 89%. So this is concerning, of course, because we want only one single calibration model that is going to predict the amount of leaves. And this model should not care about the soil or should not care about the variety. So in that ideal scenario, if I generate one single calibration model that doesn't care about these effects, I'm going to get an R² of 88%. It's a little lower, but this is still acceptable, and it's still confirming that the NIR can be used to measure the amount of leaves in the shredded cane samples. That's all for the results. I'm just happy to share with you that this research has been producing some impact in the industry. Right now, 2 companies, one of the biggest farmers in Louisiana, purchased an NIR. It's a smaller version than the NIR that I'm using. It's the Tango. It's just a smaller, it's portable, it's cheaper, and they're going to use this for pre-harvest analysis. And one Louisiana factory also purchased the same NIR, the Tango version, the smaller one, and they're going to start calibrating the equipment to analyze juice, as it was the recommendation for this research, to be able to implement that into the payment system in a future. So both companies are just starting with the calibrations, and that's a work for a couple of years. As a conclusion, the NIR can be implemented in the Louisiana payment system, starting only with juice, because the results were really promising for pole and bricks. The moisture methodology you are using in your factories is overestimating the moisture content. The NIR was proven to be effective in predicting moisture only if we measure moisture at 105. And the NIR was proven to be effective in predicting the amount of leaves. And we're going to keep working in improving these methodologies, these calibration models, using nonlinear methodologies. Because, as Dr. James explained earlier, the software that are already implemented with the NIRs use linear models, and we are going to try to use nonlinear models to improve the calibrations. Finally, I just want to thank the American Sugarcane League, because they have been funding my research, and all the staff from the Sugar Research Station, Jason Boss from John Deere, because they helped me with the preparation of the samples for the mixtures. And these guys from the LSU and USDA helped me with the analysis of the soil types and the maps. Thank you so much. Yeah, that's a huge concern, but I just can show you the results and the truth. And you are overestimating moisture, and you are just trusting a result, a methodology that is not accurate. So right now I'm just showing you that, and I'm showing you that NIR is calibrated with 105 and works. But it's not up to me to say what are we going to do with the cane payment. I'm just showing results right now. Yeah.
Coal moisture, expedient bricks, coal moisture, in process.
Yeah, actually from last year, I include those results in my presentation from last year, because we already have calibrations for pressed juice, filtered juice, syrup, and the results are pretty great too. The calibrations have an R² above 90% too. And that's something that I forgot to mention. The NIR, we are insisting too much with this technology because it's already been used in different countries. Not only for payment system, as you said. So in Australia, for example, they are using NIR for payment. The payment is different to our payment system, but they are using. In Florida, they are also using NIR for payment, but their payment is based on juice. And that's why, because they know that the NIR works better with liquid samples, and they are based on that. And in other countries, yeah, they are using for materials inside the factory, yeah. Any other question? Okay, thank you.